definition of a computer. So everybody has been using this computer for quite a long time. So what is a computer? Computer is a fast electronic calculating machine that accepts digitized input information, process it according to a list of internally stored instructions, and produces the resulting output information. So basically, computer is a programmable electronic device. It accepts the data. This data can be number, it can be an alphabet from your keyboard, or it can be an audio signal, it can be a video signal, anything, and performs some mathematical or logical operations on the data based on the stored instructions in its memory and gives us the output. So these are the basic functions that are performed by a computer. These computers can be classified into 4 major categories. So the modern computers, like they can be classified into 4 major categories. First category is embedded computer. Second category is personal computer. Third category is servers and enterprise systems. Fourth category is supercomputers and grid computers. So coming to the first category, that is embedded computers. So the best live example of this embedded computer is your mobile phone. So what does embedded computers do? These are integrated into a large device or system, and they are used for specific purposes only. For example, if I want to design an automated locking system, or a biometric locking system, your biometric attendance system. So for specific applications, we design certain, we use certain computers. So those are called as embedded computers. The examples are your Arduino Uno board, your Raspberry Pi. So these are some examples of your embedded computers. The next is your personal computer. So most of them are very much useful to this personal computer. So we are using this in our day-to-day life. So these are used in your homes, your educational institutions, your businesses and offices. So these are used for general purpose computations only, and it can be also used for document preparation, your computer aided design, audio visual entertainment, and can also be used for browsing internet. So if I see a personal computer, any computer consists of the input devices. The input devices are keyboard, mouse, and the output devices is monitor and a printer. So it consists of a CPU, which is the brain of the computer, also called central processing unit. So all the processing that are given through the input devices is processed in this CPU, and the output can be displayed on the screen through the monitor, or it can be given as a print through the printer. So coming and other storage device, there are several storage devices that are there. They are, you can say, ROM, RAM, flash memory. So all these comes under the storage devices. The next is the servers and enterprise systems. So generally, enterprise systems are used for business data processing, which require more computing and storage capability than the desktop computers. Coming to servers, servers contain sizable database storage units and are capable of handling large volumes of requests to access the data. So hence they require large storage capacity for the memory. When coming to supercomputers, so these are used for large scale numerical calculations which are required in several applications such as aircraft design simulations, weather forecasting, etc. And all this scientific work which involves more number of computations which cannot be performed by the general computer will be taken up by the supercomputers. Then coming to what is computer architecture and organization. So as I discussed earlier, computer organization and architecture is the study of internal working, structuring and implementation of a computer system. So in this, if you want to know about the computer architecture, it deals with the structure and behavior of various functional units of a computer. So there are several functional units inside a computer, like input output devices, your arithmetic and logic units, your timing and control circuits. So there are several functional units in the computer. So all these constitute what is called as computer architecture. So a best example of a computer architecture is your ARM architecture, your von Neumann architecture. So these are several computer architectures. So coming to computer organization deals with the how the hardware components are connected to form a computer. So here we deal with only the hardware components of a computer. So in this course, we'll be learning about both the computer architecture and the computer organization. So this is about computer architecture and organization. And coming to this very interesting question, why should we study this course? So many of you are using the computer, but most of us do not know what are the internal structures that are present inside the computer and how these internal structures communicate with each other to perform a specific task. So all this information you can gain by studying this course. After studying this course, you will be able to design, develop and implement applications in better, faster and in a more efficient manner. So apart from this, so there are several core companies that are present for recruiting. So what are the core companies? Your HP, Intel, Samsung, Nokia, LG, so all IBM. So these are several core companies. So in order to go for this recruitment process, you need to know more about the computer, its architecture and its organization. So this plays a very important role in finding you a job in the core company. And this course is also useful for attempting competitive exams like GATE, ISRO and other government examinations. So this is the usefulness of this course. So everybody knew what is, so if you study this course, you will be knowing the deep knowledge about what is inside the computer rather than using the computer. Coming to the course objectives, so there are the following are the course objectives. So the first objective of the course tells us that we'll be able to gain the comprehensive knowledge of computer system, including its analysis and design of components of a system. Like if you take a computer, there are several components that are present inside the computer. So we'll be able to learn about those components. The second objective is it gives us a view of computer system from the user's perspective. That means the one who is using the computer should know everything regarding what is inside the computer. And then representation of data. So a computer processes the input in the form of data. So these data are generally in the form of instructions. So several instructions will form something called as a program. So these programs are used to perform a specific task. And the fourth is the illustration of data path. What do you mean by data path? Data path is how the data is being transferred from input device to output device. So this data is transferred from input to output and how the control signals are used. All these things comes under the data path. And then you will be able to illustrate several algorithms for the basic arithmetic operations using your binary and decimal representation. So and lastly, we will be dealing with the interaction devices with the CPU, how the input-output devices are interacting with this CPU, its characteristics, their modes, and then we go for the multiprocessors. And this is the course outline. So basically, this course on computer architecture and organization will be very much useful for your future subjects. So the future subjects will be your microcontrollers, your microprocessors. So the computer architecture and organization provides you the basics to understand the higher level languages, higher level subjects like MPMC, etc. Okay. So in the course outline, in the first unit, we'll be discussing about the basic structure of computers. So in this basic structure, we'll be dealing with the functional unit, what are the basic operational concepts, like what are the buses that are present, what do you mean by system software, and then how to measure the performance of a system, and in brief, and the end, we'll be studying about the brief history of this computer development. That is what is first generation of computer, second generation of computer, third generation, fourth generation, etc. So how the computers have evolved over the past few decades, we'll be studying in the unit 1. And coming to the second unit, the machine instruction and programs. In this, we'll be studying about what are the basic instructions that are there, that are present to perform a task. For example, we'll be studying about what are the logical instructions, what are the arithmetic instructions, and how the input, what are the basic input-output operations that can be performed, what is the addressing modes that are there, and then the basics of the shift and rotate instructions. So these instructions will help us in manipulating the data. And the third unit will be studying about the different types of instructions, like branching instructions, and we'll be studying more about deeper into what is different types of arithmetic operations that you can perform, and then how these are performed, and what are the different addressing modes that are present. And also we'll be dealing with how the input, what are the operations between the input and output devices. And the fourth unit, that is called as input and output organization. So in this unit, we'll be dealing about the interrupts. So what is meant by interrupts, how to enable and disable these interrupts, and what is meant by direct memory access. Okay, and then we'll be also discussing about what are the different types of buses that are present which are helpful for the movement of the data, like synchronous bus, asynchronous bus, and we also study about your standard input-output interfaces, that is your USB. So universal serial bus, we'll be studying about this universal serial bus, and also peripheral component interconnect, your PCI. So these are the standard input-output interfaces. So we'll be studying about these in the unit 4. And in unit 5, we'll be studying mostly about your memory systems. So what is meant by primary memory, what is secondary memory, how the data is stored in the primary memory, or how the data can be stored in the magnetic disks, that is in secondary storage or optical disk, and what is meant by cache memory. So all these things will help us to know about how the memory is designed. So this is one of the functional unit of a basic component of a computer, that is the memory. So in this unit 5, we'll be dealing about the memory systems. And finally, at the end, this is the 6th unit, we'll be discussing about the processing unit. So how the CPU processes the information, how the instruction is fetched and decoded. So all this information we'll be studying in the processing unit. We'll be also studying how the instructions are executed in the CPU. We'll also study about what is meant by hardwired control and what is microprogrammed control. So what are the micro instructions and what are the hardware control instructions? So these are the course outline. So in the first 3 units, we'll be studying about the basics of computer, the basic instructions that are needed and basic programs, and then what are the arithmetic and logical instructions and the branching instructions. And coming to the last 3 units, we'll be concentrating on the input-output devices, their interfacing, the memory system, and finally the CPU or the processing unit. So this is the course outline. Coming to the course outcome, so the first course outcome, by this course, the student will be able to understand the basic concepts of a computer, including CPU, its memory unit, its input-output devices, and their organization. In CO2, the student will be able to get familiar with the representation of data, how the data is represented, how you can represent the data, how the data is encoded, how the data is decoded by the computer, and what are the instruction sets that are present inside the computer, how the logical and shift and rotate operations are performed by this computer. So this is the course outcome number 2. The course outcome number 3, the student will acquire the basic knowledge on arithmetic, logic, and branch instructions. So these will improve his or her programming capability. So how the arithmetic and logic instructions are performed, how to perform a loop, how to introduce a delay. So all these things are the course outcome of the number 3. And then in course outcome number 4, the student will get the ability to understand the input-output organization. So he will understand how to handle multiple devices, how to handle the buses, how to handle the interface circuits. And then CO number 5, the student will be able to understand the organization of memory and memory management system. And CO number 6, the student will be able to understand how the instruction is performed by the processing unit, and he also develops the basic knowledge on the organization of control unit. So these are the course outcomes of computer architecture and organization. Coming to the course prerequisites. So there are some certain prerequisites of this course. So under prerequisites, you need to know about the basic knowledge of number system, which you have already studied in your second year, that is switching theory and logic design, or the digital circuits, we say. So all the combinational circuits like encoders, decoders, your multiplexers, adders, subtractors. So these all will be very much useful for the design of the arithmetic and logic unit. And in the sequential circuits and the finite state machines, you have already learned about how the clock works. So here we'll be also dealing with the timing analysis of the read cycle, write cycle. Okay, so all these things we'll be discussing. The basics of that is found in the switching theory and logic design, which is the course prerequisite. And coming to the textbooks and references. So here the first textbook which we need to follow is Computer Organization by Karl Hamacher and Computer Architecture and Organization by John P. Hayes. So the rest are several references which you can follow. So finally, I would like to conclude that this computer architecture and organization will give you dual advantage of knowing the software as well as the hardware of a computer. So till now you have used the computer as a layman, but now after studying this course on computer architecture and organization, you will be able to develop, or you can be able to design a simple application, how the data can be routed inside a computer, and how you'll be able to understand the memory architecture and that is present inside the computer, and how the data is stored in the magnetic disks. So based on all these things, you can gain both software knowledge as well as hardware knowledge, which will be helpful for you in getting a job in core companies. Not only that, this subject will also be helpful for understanding your future subjects like like microcontrollers, microprocessors, ARM controllers, like that. And in order to design any application, any specific application, you need to know about the embedded computer. So if you know about the computer architecture and its organization, you can easily design a specific a computer called an embedded computer for a specific application like your IoT, etc. So with this, I will conclude. Thank you.